Hi, my name is Kovács Márton and I am a PhD student at ELTE Chemical Kinetics Laboratory. My research area is testing and development of detailed combustion reaction mechanisms. In our previous video, entitled Testing a Combustion Reaction Mechanism, we have shown that using RKD format XML files and the graphical user interface of our Optima++ code, a mechanism can be tested very quickly and easily on a modern multi-core computer. This option is viable if we use less than 100 spatially homogeneous experiments for testing. Ignition delay times measured in shock tubes or rapid compression machines, concentrations measured in perfectly stirred reactors, flow reactors, or shock tubes are examples of experimental facilities that can be simulated as spatially homogeneous systems. If we use more than 100 homogeneous experiments for testing, or consider also laminar burning velocity measurements or species profiles determined in burner-stabilized flames, the more computer power is needed that is offered by a desktop PC. Computer clusters available within the research groups or at a computer center provide enough computational power. However, these computers are usually not accessible via graphical program interface and the command-line approach is needed. Optima++ allows testing reaction mechanisms on remote computer clusters using command-line operation mode. This PC will be used as my host PC for starting the simulations and viewing at the results, but the actual calculations will be carried out on a remote computer cluster. I have opened a terminal window, and I copy the Lee 2007 mechanism and the content of the XMLs folder to the head computer of our cluster. Previously, I downloaded 10 ignition delay time measurement XML files from the RESPECT site. I use here the scp command for transferring these files. On Windows, you can use WinRCP for this purpose. Now, I log into the server using the SSH command. I navigate to the tutorials folder where Optima++ has been installed. To check if Optima++ is working correctly, we may run it with the -v argument. It will list the available solvers. Here we have FlameMaster 4.2.1 and OpenSmoke 0.12.0. Now I create the input file for Optima++. This is a simple text file, so you can use any text editor. I expand the template input text here, and we will go through the file line by line. This template text is available on the web page related to this video. For each job in Optima++, there is a corresponding input block. And the input block begins with the name of the job and it is closed with the end keyword. The name of the input block for mechanism testing is MECHTEST. However, the MECHTEST job requires a compiled mechanism. This is why there is a MECHMOD block first. The MECHMOD block can be used for mechanism compilation. Converting the mechanism into the internal format of the solver, or for the modification of the mechanism. For example, for removing or renaming species. In the first step, I assign an identifier for our mechanism in the MECHMOD block. This name will be used in the other blocks as a reference to that mechanism. In the next line, I enter the relative path to the mechanism file. The next command is for mechanism compilation. We can compile the mechanism either with FlameMaster or OpenSmoke++. Now I choose FlameMaster. The compile fm command requires a path name, where the compiled mechanism will be saved. Now I jump into the MechTest block. The mechanism name was auto-completed. In the next line, I set the thread limit to 48. The thread limit is the maximum number of the simultaneously running FlameMaster simulations on the cluster. Finally, we can enter the relative path to the selected XML files. I quickly list the 10 files uploaded earlier and prepend them with the name keyword. Optionally, we can provide the standard deviation of the experimental data after the sigm keyword. This triggers the evaluation of the error function and adds error bar to the final plots. After the sigm keyword, we have to define the scale of the standard deviation. It is ups for absolute and upsilon for relative errors. I assign here 10% relative error to each point in each XML file. Now, we are ready to run Optima++. To run Optima++, we have to pass the name of the input file as a command line parameter. The actual command how to send the job to the cluster computer depends on the software architecture of the cluster. Here I used a bash script which was written to send Optima++ jobs to our cluster. If you are planning to use Optima++ on a different type of cluster, please consult the cluster's documentation for details. Using computer clusters, you may run simulations for several days on several hundred cores in parallel. You may check the progress of the calculations on the cluster, and when all calculations have been finished, you may process and visualize the simulation results on the host PC. The result files are saved to the output folder. Now I download the content of this folder from the server to my local computer. I open this folder in a file browser. The simulation results are saved to the file called MechTest results. This is a simple text file, and these results are also saved to a CSV file, which can be directly imported to Excel or to any spreadsheet program for easier post-processing. Optima++ can detect if GNUplot is available on the host computer. If it is installed, Optima++ will generate comparison figures for each XML file referenced in the input file. As you can see, the Lee 2007 mechanism gave simulation results in good agreement with the experimental data. We can also use the graphical interface of the Optima++ to analyze the downloaded results. Just simply drag and drop the MechTest results file to the main window of the program. If we go to the Plots tab, we can look at the comparison figures generated for each XML file. These plots are interactive. We can drag it or zoom in or out using the left mouse button and the mouse wheel. If we move the mouse pointer above the axis and zoom, only the selected axis will be zoomed. As you can see, the Lee 2007 mechanism reproduced the measured ignition delay times very well. On the error function values page, we can calculate the error function value by clicking on the calculator button. The error function is also calculated for each XML file on the By Dataset tab and for each point separately on the last tab. This was a demonstration that simulation with large number of experimental data points or flame simulations requiring much computer time can be carried out in an effective way on a computer cluster using ArcGD format XML files and the command line operation mode of Optima++. Thank you for watching and take care.